Hello everyone, today we're going to do Math 6, Mission 8, Lesson 6, histograms. So we have talked a tiny bit about bar graphs, and bar graphs are not histograms. So bar graphs do not equal histograms. So I want to make that clear before we start. We've also talked a lot about dot plots. And dot plots and histograms go together. All right, let's start with our warm-up. Here's a dot plot showing the weights in pounds of 40 dogs at a dog show. So we have 40 dogs. That means there should be 40 total dots. 1, write 2 statistical questions that can be answered using the dot plot. There's lots of ones that you can choose, but I'm going to do: how many dogs weigh exactly 70 pounds? And how much does the heaviest dog at the dog show weigh? Both of those can be answered with our dot plot. 2, what would you consider a typical weight for a dog at this dog show? Explain your reasoning. So if I look, the distribution kind of goes like that. So the middle section, or the center, remember that word from last time? Center. I would say falls somewhere around here, maybe? That might be a little too high. Maybe more around here. Yeah? So between 100 and 110. So any number between 100 or 110 will be good. So let's say about 100 pounds. Because if you look, about half of the dogs are below that weight and half the dogs are above that weight. So it's close to the center of our data. Okay, activity 1. Here is a histogram that shows some dog weights in pounds. So we need to discuss what a histogram is. All right, a histogram takes the data points that you can find on a dot plot and it groups it into bins. So a histogram groups data into what they like to call bins. So it's groups of data where a dot plot shows us individual data points. So there are, in this one right here, we can see there are 6 total data points in this bar. 6 data points. We don't know exactly what the data points are, but we do know they fall between 60 and just below 80. They don't quite make it to 80 yet. 80 is in this data point. But if we go to a dot plot, we would be able to see those 6 individual data points. So a dot plot has individual data points. Now there's a reason that we use dot plots or histograms. Histograms come in handy when there are so many data points that it's too hard to distinguish them on a dot plot. And we're going to see that today. So let's jump into activity 1. Each bar includes the left end value, but not the right end value. For example, the first bar includes dogs that weigh 60 pounds and 68 pounds, but not 80 pounds. Like I said, 80 goes with this bar, 100 goes with this bar, 120 goes with this one, 140 goes into this, and 160 goes into this one. So the number always goes with the bar above it. All right, use the histogram to answer the following questions. 1, how many dogs weigh at least 100 pounds? Okay, so we need to go find 100. So here's 100. So remember that 100 goes with this bar. So we're going to look at all of the data points above this point. So this bar goes to 14. So we have 14 data points in this bar. Let's look at this one. That's between 4 and 6, so I would say 5. How about this one? That one is 3, and then this one is 1. So to answer A, we're going to add up all of those numbers. So 14 plus 5 plus 3 plus 1. Woo. So we have 19 plus 3, 22 plus 1 is 23. So there are 23 dogs that are at least 100 pounds. Let's try B. How many dogs weigh exactly 70 pounds? This one's tricky. We know that 70 is going to be in this bin, right? This group of data points, but we don't know if 70 is actually a data point. It could be, or it could not be. We could have 60, 68, 69, 69, and 69, and then another 69, right? Or 74, or, there's a lot of data points. We know that there are at least 6, but we don't know specifically. So this is unknown. It could be anywhere from 0 to 6. C, how many dogs weigh at least 120 and less than 160 pounds? We can figure that out. So 120 goes to this one, and less than 160. So here's 160. So we are looking at these 2 histogram bars. So that would mean we would have to do 5 plus 3, which gets us 8 dogs. How much does the heaviest dog at the show weigh? You might be tempted to say 180, but that would be wrong. We don't know. It can't be determined, right? So unknown. But we do know that it has to be between 160 and 180. We know there's one data point in there, and it has to be between 160, but less than 180, because 180 would go with the next bar over. So 160 to less than 180. But we don't know the exact weight. If we had a dot plot, we could know the exact weight. What would you consider a typical weight for a dog at this dog show? So again, we're looking at our histogram. And erase this here. We can see those numbers better. So the majority of the dogs, this one is 11, and this one is 6. So that's 17. So we have 17 on this side, and we have 9 on this side. So our middle is somewhere in this bar. So I would assume that our dog is around, or the average weight of our dogs is around 100 pounds. Because that's where the center of our data is. Remember, when we're talking typical, we mean the center. We're going to skip that. Moving on to activity 2. All right. The dot plot shows the population data from the 2010 census for each of the 50 states and the District of Columbia. So how many dots should we have here? Because we have the 50 states and District of Columbia. So we have 50 plus 1, so there should be 51 dots. A census is where they go around to each household and they ask how many household members they have living there, and they take a tally, and that helps us know population movement, population growth in an area. It's a pretty cool thing, to be honest. All right, so let's look at our dots. So every 10 years, the United States conducts a census, which is an effort to count the entire population. This is the population of the states in millions. So we are talking millions, not 25 people, right? 25 million people. All right, number 1 says, here are some statistical questions about the population of the 50 states and DC. How difficult would it be to answer the questions using the dot plot? All right, so how many states have populations greater than 15 million? Well, let's go find 15 million. Here's 15 million. So how many greater? Well, we have 1, 2, 3, 4 dots. So using the dot plot, that should be pretty easy, right? We can see. Unless some dots are lying directly on top of one another, there are 4 states with a population greater than 15. We're just going to do the dot plot first. Okay. The dot plot column first. Which states have populations greater than 15? Well, it's asking for specific state names. Are the states named on the dot plot? So that would be not just hard, but impossible to answer. So that's an impossible to answer because the dots aren't labeled. C, how many states have populations less than 5 million? Ooh, okay, so look, this is our 5 million mark, but because the dots are so close together, this is an impossible task. We can't see them. We might have dots on top of each other. D, what is a typical state population? So this one is really hard. Since so many dots are indistinguishable, meaning you can't really tell where they are, it's hard to determine a typical state population. Are there more states with fewer than 5 million people or more states with between 5 and 10 million people? Again, this one is going to be hard. It appears that there are more dots for populations that are less than 5 million than those for between 5 million and 10 million, but we can't be sure because the dots might be right on top of each other. Because remember, unlike when it's 10 million and we have dots on top of each other to indicate how many 10 million people live in each state. You could have 10,000,001 people, and that would require a new dot just to the right of 10 million. So it's really hard to determine. How would you describe the distribution of state populations? This, again, is really hard. Since the dots overlap a lot, it's difficult to give a good estimate for the center and the spread because we can't tell how many dots are right here. So we can't tell where to split it in half. Okay, so let's keep going. We are going to come back to using the histogram. Here are the population data for all states in the District of Columbia from the 2010 census. Use the information to complete the table. All right, so now we have all of the data points. We are going to look for populations between 0 and 5 million. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So our frequency is 29. All right, let's do 5 to 10. 1, 2, 3, oops, I missed one. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alrighty. 10 to 15. So that includes 10. So here we go. Nope, too high. There's 1, 2, 3. Looks like just 3. 15 to 20. 15 to 20. There's 1, 2, 2. 20 to 25. I don't see any. 25 to 30. There's 25 and 1500. So we have 1. 30 to 35. The only one I see left is this one, and it is 37. So that would be a 0 and then 1 right there. All right, so we've got our frequency table finished. Let's keep going. Use the grid and the information in your table to create a histogram. All right, so 0 to 5, we have 29. So this should come all the way up here. And histograms touch. Unlike bar graphs don't touch. But histograms do because they get so close to each other. Those numbers get very close to each other. All right, so there's my first bar. Now we need 5 to 10. So that's 15. So we're going to go over here and find 15. Color that in. You can do a much better job coloring than I can. All right. 10 to 15 is 3. Fifteen to 20 is 2. 20 to 25 is 0. 25 to 30 is 1. So we'll go 25 to 30 is 1. 30 to 35 is also 0. Yep, and 35 to 40 is 1. All right, we have created our histogram. Now it says, return to the statistical questions at the beginning of the activity. Which ones are now easier to answer? In the last column of the table, rate each question with easy, hard, or impossible. All right, so let's jump back up to that one. Here we go. So how many states have populations greater than 15 million? So if we jump back down to our histogram, here's 15 million. So we want what's greater than that. Well, this is a 2, this is a 1, and this is a 1. So that's 4. So that should be easy. Still easy. Which states have populations greater than 15 million? This is still impossible. None of the data points are labeled, at least based on the histogram. Remember, we're just talking about the histogram, not this table, because this table, obviously, we could figure that out, but we're not talking about the table, just the histogram, and those aren't labeled. How many states have populations less than 5 million? Who? Less than 5 million. So here's 5 million, and remember that one goes into there. So we need how many are just in this first bar, and we know that is 29. So we can now easily answer this question. All right, what is a typical state population? Remember, we're looking for that middle, that center of our histogram. So we have 29. This one is, woo, my page ran away from me. So this one is, what is that, 15? This one's 3. So we have 29, and then we have 15 plus 3, 18, 19, 20, 22. So our center is going to be somewhere in this first bar, that first bar. So I would say from the histogram, we can estimate that a typical state population has fewer than 10 million, but it's hard to be more precise than that. So we're going to call that hard. E, are there more states with fewer than 5 million people or more states with between 5 and 10 million people? Using the histogram, so less than 5 million people or between 5 and 10. Look, this is less than 5 million people, and this is between 5 and 10. So we know 29 states have less than 5 million, and 15 have 5 to 10. So I gotta say that's easy. All right, last one. How would you describe the distribution of state populations? This one, super easy. We can now describe the data distribution more precisely because the histogram shows the population sizes in intervals of 5 million. So I can say, ooh, 29 states have less than 5 million people living in them. So that's easy. All right. So again, what I want you to remember is that histograms place the data values into groups or bins. So these are groups. So we can't tell individual data points, but sometimes a histogram makes it easier to analyze the data. Okay. So you can see the difference between this dot plot where we can't really tell a difference to this histogram where we can now have conversations about the data. So just a review, a histogram groups data points into bins, for easier analysis. Okay? Now, I want to show you what a bar graph looks like one more time so that we can show the difference. Okay? So a bar graph looks something like this, but this is going to be categories. Our bar graph is going to be categories down here, like lemon, grapes, right? And then we're still going to have numbers over here, 1, 2, 3, 4, 5, right? But I would say, ooh, I have 5 lemons in my fruit basket. And I only have 2 bunches of grapes in my fruit basket. A bar graph, this is a bar graph, goes with categorical data, whereas a histogram goes with numerical. So this is going to be categorical, and this is going to be numerical. Bar graphs don't touch each other. Histograms do touch each other. All right.